Alright, we're going to continue Chapter 7, and now we're at 7.1.2, and we're going to talk about IP version 4, and we're going to talk more specific about the addressing for that. So a little review. We talked about what's in, and we've talked about the conversions. Okay, now we're going to talk about the structure of the address. So this part is done. Let's do the conversions. We talked about addresses represented in ones and then represented as an IP address. These IP addresses have to be on a certain network on each side of the router. So really the router has separated here. It looks like a network going out to the internet, a network going this way, and a network going this way. We talked already about a little terminology. Decimal address, we divide it in octets, groups of 8 octet, that's where the word, and we have a 32-bit address. So this is what the router sees, or the computers and devices as far as addresses, and this is what us humans look at so that we can understand it. Okay. We talked about the positional notation, and we went over base 10, and we talked about an example here. And then base 2 is what we'll be using, binary digit, or a bit. That comes from the word binary digit, a bit. And then we can see the representations right here. And we talked about then one to another. Now this number can be represented here by looking at where those ones are and adding those together. Okay, and then we did the conversion the other way. Okay, so this was still what we just talked about, and then 168 where the bits fit in here, and you add them up. Alright, same thing here. There's the bits, that's what we add up, that's how we get a 10. We have one group of 8. We have one group of 2. That's how we get the 10. And then to convert the other way, you're going to see how many 128s you can take out of whatever octet you're looking at. Get that first, and then see if you can take a 64th. And so then you do that until you have all of the bits in there. So then the example we did here, 192, we took a 168 out, so we have a 1 there, we have 64 left. Then we take one group of 64, subtract, now we have zeros, so the rest of these will be zeros. So this number represents the same thing as 192. This is what the computer router sees, this is what us humans see. And so then we can go on here with this, represent that. Alright, here where we are now. Let's talk about IP addressing structure. Okay. IP addresses, you have a network part and a host part. The host represents the device on the end, you know, whatever that might be. We'll use the example of a computer, and this represents the network part. You know, in terms of when it hits a router, the router needs to look at the network part and decide which network it sends to, and if it doesn't have a network, if there's a default gateway, it sends it out the default gateway. Okay, so that's the first thing. We have the network part of the address, and we have the host portion of the address. This identifies a specific host, and this identifies a specific network. Let's move on. We have then something that looks like this, which we configure in the computer. We can see we've given that computer a host address, and a mask is going to indicate which part's the network. And then in this case we have that default gateway. So send it to this if it can't figure out where it is within the network. And of course, in most situations, you'd have a DNS server also configured. So they also domain names. Okay? Now, next key thing, subnet mask. Subnet mask, right here, 255, 255, 255, 0. These ones then indicate which part of the address is the network. Okay? This over here then, everything else is the host. So we have an IP address, and we have the mask, and then that indicates which part is host network. So we have this here group that we can use to number all of our devices. And we're going to talk more about that here in just a minute. And this part is going to be the network. So when a router gets this, it knows where to send you. So what the router does, it does this AND comparison between the two bits. It's called ANDing. When it gets a 1 and a 1, it creates a 1. Okay? When it gets a 1 and a 0, it creates a 0. And so what happens is when we have a address and the mask, and it ANDs them, here's the AND results. It ends up, the mask, these are all zeros, and so when it ANDs this, it doesn't make a difference what this is going to be all zeros. So this way, the router, the routing device, knows that this part of the address is the network, and it doesn't have to worry about the host, at least not right here when deciding where to send the packets. Even if this is a little confusing at this point, here's the rules. It's important to understand the key thing here is that the mask allows the router to look at an address and decide which results end up being the network part of the address. Prefix length is another way to represent the mask. So we just looked at the example of this mask, which is this 255. 255 is all ones, if you calculated that out. So we got 255, 255, and then 0, which is all zeros. We have here then 24 prefix bits, right? 8, 8, 8, we have 24, so you can use the /24 to represent that. Here we only have 8 prefix bits, it'd be a /8, the 255. So you'll see these used quite a bit in our addressing, and we'll be talking about them as we go along. So that's all of these representations here. I just circled the one example. So it's a shorthand method of identifying the subnet mask. So we have an address that represents the network. Then we can have an address that represents the host on the network. And then we have broadcast addresses also. And this would be the last part that we'll look at here. Okay? So let's move to look at some of these examples. A network address. The host portion is all zeros. And so this represents the network. Okay? So the network part for up here, for all of these devices, the network part, if I can do this without making a mess, you notice they all have 10, 1, 1, 10, 1, 1, 10, 1, 1, 10, 1, 1, 10, 1, 1. That's the network. This router knows if it gets an address for 10, 1, 1, it doesn't make a difference what the host part is, because it says 10, 1, 1, send the information that way. When it hits a switch, the MAC address is going to get it to the correct device. And how does it get that MAC address? So this router is going to keep track. It's going to have an IP, and it's going to have a MAC. address resolution protocol, so it has those matched up. So when it sends this out, it's going to have the right MAC address on it, because it's going to keep track of them. Okay? So if it needs to go to this one, it'll have the MAC address for that one matched up with that address, that host address. And then when it hits the switch, there it goes. It doesn't actually make that noise, I just made that. Alright. Okay, so that's how that works. So the router needs to know which network to send it out of, and then on the way out, it matches up the MAC address with the IP address in that address resolution protocol. Okay, so let's keep moving. Network address. A host address is the specific address on the network. These are all host addresses on the network. And the router has to have a host address also. They all need a host address. Okay? So these are all host addresses. So we just covered a network address and a host address, then the last one's a broadcast address. Here's the first host address. Okay, I used a 1 there. Okay, again, here's the network. Last host address, 254. Okay, and the reason that can't be all 1s is because when that's all 1s, that's a broadcast. So let's look at that. Okay, so here's the last host address. Move into the broadcast address. This is all 1s. So for this network, we don't have a video right now. For this network, if we were to look at how this is working, so we have 10.1.1.1 is the first host address. Okay, 10.1.1.254 is the last host address. Those are all host addresses, including the router and all the rest of these. However, you know, all those 200 and whatever you can put on there. And then we have 10.1.1.255. That's the broadcast. And if you look at the address like this, 10.1.1.0, 0 there, that's considered then the network address. So that's a specific network address. So we have the network address, then we have all these host addresses, and then we have the broadcast address. That's it.